So video 1 on solving special right triangles. So you're going to use what you learned from the origins and what makes up a special right triangle and or Pythagorean theorem. Both work for you, but today I'm going to practice just using those rules so you can see the benefit for some of them for the memorization of that rule. So that would mean like your 45, 45. So this is a 45, this is a 45. So our two sides, we know this is going to be congruent to this, and then our hypotenuse is always going to be x square root of 2. For a 45, 45, that is the ratio to each side. Now, these can be really simple, and sometimes they can get a little more difficult depending, obviously, like 2 times the square root of 2 is not a nice, easy number, but we can do this. Otherwise, you can use your Pythagorean theorem if you have two sides, or if you remember with 45, 45, that means you know base angles are the same. These two sides should be the same, and that's a throwback to just properties of triangles, which is why we know this is x and this is x. So we know that b is going to be 2 square roots of 2. So if these two are 2 square roots of 2, and then I can just plug that right on in, x times the square root of 2. So that's going to be 2 square roots of 2 from our a and our b leg, and then we're going to multiply that by the square root of 2 because we've plugged it in for x. Sorry, I'm looking for a pen that I can erase with. There we go. So times the square root of 2 because we plugged that in the place of x. Now, if you remember multiplying radicals, you multiply things that are like, this is a whole number, so it's going to just fall down for now. So it's going to be 2. And then the square root of 2 times the square root of 2 is going to be the square root of 4. So I'll write that up here just as a reminder. But the square root of 4, we know is 2. The other way you can remember that is if you multiply a square root of anything, because that's the same thing as doing the square root of 2 squared, and we discussed those are inverse operations, will give us 2. So it's going to be 2 times 2, and that's going to give us 4. So then A should be equal to 4. So A equals 4, B equals 2 square roots of 2. All right, so moving on to example number 2. Again, this is a 45, 45, 90, because if I have 90 used and I have 45 used, I know it has to be 45 left because the 3 interior angles of a triangle have to equal 180. And then I know that these two sides will always be the same because of base angles being congruent. And then 4 is going to be x times the square root of 2 for that side. The hypotenuse is always x square roots of 2. So to be able to solve for x and y, I know that 4 is equal to x square roots of 2. Now I got to get x by itself, so we're going to divide both sides by the square root of 2. Square root of 2. We don't want a square root of 2 on the bottom, so we're going to take that 4 over square root of 2, and we're going to multiply it by square root of 2 over square root of 2, because that's the same thing as 1. And multiplying anything by 1 doesn't really actually change the numbers. So I now have 4 square roots of 2 over, remember when you multiply it by itself, we just get a 2. And we can simplify this 4 and that 2, if you remember back when we were doing our radicals. So that's going to become 2 over 1. So x equals 2 square roots of 2. And because we know that x and y are the same because of those congruent base angles, then we also know y is 2 square roots of 2 as well. All right, I'll stop the video there. There's 2 of your 44, 45, 45, 90 solving for sides examples. Look forward to the next video.